Okay, here's number one. Now, if you read it, they were talking about these houses that are between 200 and 400,000 right here. Most of the houses are in that range, but you have a couple of houses that are really expensive. Let's see what that graph would look like if we drew that graph. So something like this, right? And you've got, I'll label the axis. So it might look something like this. So what they're saying is you have a bunch of houses that are in this range, right? But then you happen to have just a couple way out here, there. So remember, this is like a whole bunch of houses, right? And then you just have a couple that are in this really high price range. Now you can probably answer this question. I'm not going to look at the, I'm just going to say that it is skewed, what, to the right? Okay, let's see what it says. I'm thinking it's going to be choice D. Okay, let me double check. I was right. Let's do the next one. Okay, number 2. Ooh, that's tricky. Here we go. 40 inches tall, right? Puts that kid at the 90th percentile. Now the middle, the average, is what, 38? So I really need to know how many standard deviations above, right, is the 90th percentile. And I do that by doing inverse norm, if you remember that. So let's see, inverse norm. Let's see what that number is. How many standard deviations is the 90th percentile? So it turns out that the 90th percentile is 1.28 standard deviations above average. So one way to think about this is we say, well, the difference between these two is 2, right? So what number times 1.28 equals 2? Let's see. What number times 1.28, so mystery number x, gives us 2 as an answer. So divide both sides by 1.28, and you get 1.56, dividing both sides. So you get 1.56 should be the standard deviation, and that's letter E. And another way to think about this is, remember, z-score is equal to what? The number we're interested in minus the average divided by the standard deviation. Let's see. So this was our z-score, 1.28. 1.28 is equal to 40 minus 38 divided by standard deviation. And essentially, if we did this algebra over here, we would end up with the same thing that I came up with. So, letter E. Okay, this one, let's see. Large set of test scores, mean is 60, standard deviation of 18. If each is doubled, and then 5 is subtracted from the result. Okay, so remember, for the mean we would do both of those things. We would double it and then subtract 5. So 2 times 60 is 120. It would be 115. So 115 would be the new average or mean. And then don't forget that the standard deviation, we only multiply. We don't do the adding and subtracting. So let's see. Standard deviation is 18. Whoops, 18 right there. So double it, but don't subtract the 5, which would be 36 would be the standard deviation. Let's see if that's one of the choices. Ha, got it. That is letter B. Okay, so yes, don't forget. Mean is affected by all that stuff. Standard deviation is only when you multiply or divide. Okay, let's go to the next one. Okay, this might look a little bit confusing, but all we're saying is, here we go. There are 4 female rats, F1, 2, 3, and 4, and 4 male rats. And each of these rats is going to get one of these treatments. So they're going to do a block design, meaning they're going to give each one of these female rats randomly assign one of these treatments. Same thing with the male rats. Each one of these male rats is going to get one of these treatments. And then they'll compare the results. Now, what could not happen? Well, this is what they're doing here. They're saying, well, treatment A goes to female rat 1 and male rat 1. Sure. And this works. These all work, right? Each treatment goes to a female rat and a male rat. The one that does not look like it's going to work right here, letter C. This treatment B is going to 2 female rats. We don't want that because we are doing a block design. We want to compare the results between male and female. So C is not going to work. That is impossible. So let's mark that C. Okay, there you go.